In this video, we're going to walk through some of the key pieces needed to enable the CiscoZeus plugin, which is actually the treasure data plugin, on a Kubernetes environment deployed on top of a CoreOS-based platform. One of the interesting things with the CoreOS platform is that everything is run as a container. This actually changes some of the interactions that occur between Kubernetes, Docker, and the cAdvisor tools that people want to use to collect metrics from the actual containers that are deployed. To that end, the first thing that we've had to do is put together a container that includes our agent so that we can actually talk to Zeus. What we have here is a Docker file that we've used to create a Docker container based on the CentOS package that will actually install our TD-Agent, Treasure Data Agent, which is our Fluentd service on top of this container. We've had to make a couple of minor changes to ensure that we actually have access to the Docker environment still within the CoreOS system, and to ensure that we have a functional Fluentd plugin for the cAdvisor tools. We've leveraged the Fluentd cAdvisor plugin components that exist on the internet, but we've had to modify them to actually talk to the system. Specifically, the cAdvisor code wants to talk to, at least initially wanted to talk to the version 1.1 API. We've had to change that to the version 1.3 API in order to leverage most of the code within this environment. Specifically, that means that instead of just talking to containers and the Docker service within the containers, we've actually had to talk to the system slice within the subcontainer environment of the cAdvisor plugin. So this is one of the main changes we've made. In addition, because Kubernetes thinks about things in terms of pods, and pods may have multiple containers, we're actually looking at the container as pod model, but that actually means that there's an extra level of abstraction. So whereas in the past, the system, this particular plugin just looked at the response for a particular indexed container, we actually now have to look at the index itself. So there's effectively an extra layer of abstraction, and that then can be used to query all of the different information and statistics that we want to capture. So with these minor modifications, we now have a Ruby script that we can use with Fluentd. We have a Docker file that will go ahead and load this service up, but there is one other issue that we have to deal with. When we load this container, we want the container to talk to the local cAdvisor instance. Now, cAdvisor in a CoreOS environment is actually run as a service, basically a plugin service under the Kubelet system within the CoreOS environment. So CoreOS, you configure the Kubernetes services to run, and those services are run by the Kubelet agent. Well, the Kubelet agent also runs cAdvisor, but it runs it for the local service, the local machine. So we want to make sure that we do that, that we provide the right information. So for that, we have our entry point for our Docker file, for our Docker container, is actually this script. So what this script does is it gives us the ability to tweak some of the parameters of our agent before we run them. Things like what our actual data endpoint is. We can change our host name, although this doesn't usually need to be changed, at least by default in the environment. We might need to, at some point, change the shared key, so we have the ability to provide that. And our user and token for talking to CiscoZeus get passed into the system as well, so that we didn't have to try to hard code that and force everybody to build their own container. There is the ability to change the API version. Right now, this will break things if we change this, but I was using it for debugging in the past. It's also useful. At some point, we'll figure out how to update the system and provide a more efficient resource. This information that we're collecting needs to go into configuring the agent, and so our agent configuration file is bundled into this run script. This was one way of doing it. We could have also just modified the file in place. But in this particular case, we deploy this, we pass our user and our tag, get it passed here, the cAdvisor host that we're targeting, and this has to be set to the local host, set as master here. Initially, that was my understanding, but I realized then that we actually have to talk to each individual worker or minion within the Kubernetes environment, as each one of them is running its own version of the cAdvisor. So we want to make sure that we have a one-to-one mapping. This is important because the way that the cAdvisor tool still works is it still wants to talk to Docker. So this is still very much Docker-specific Kubernetes CoreOS sort of a systems environment. So it talks to the local Docker instance, gets this list of IDs, and then goes and queries the cAdvisor interface to actually understand what those resources actually are. So it's important that we have this service running on top of the system. So how do we do that? Well, that's the other part of the Kubelet environment. If we log here into the system, right there, we can log on to our master node. It doesn't actually matter any of them. We'll do the same thing, but under the Kubernetes manifest directory. So the Kubelet engine looks at this directory. It's watching this directory to find any YAML descriptions, and these YAML descriptions can be simple pods, or they can be service and pod aggregates, like most of the actual systems descriptions here are. Here we've dropped our agent file. This is one that's specific to this particular machine, and that I actually have the host name here. This is my token, which will get blurred out, and of course my username as well, which are used to go and configure the script. And then the rest of it is passed in as environment, or these are passed in as environment variables to the container, so the container can run properly. You see we've mounted our var run directory here so that we actually can talk to the Docker socket, so that we can actually get a list of containers from the Docker socket, and that's another part of what cAdvisor is going to use. So at this point, this service is actually running, and if I jump over here to the Kubernetes dashboard, just a nice quick way of looking at the system, we can see that we have our log forwarders. I have 3 instances, one host that is a master and a minion, and then 2 other minion hosts that are running. Apparently something restarted at one point a while back, and this is still my one glitch in the system, is that my DNS service keeps dying. But anyway, the DNS service isn't actually needed for this particular environment. We are actually able to get this up and running. If I pop into CiscoZeus, what we'll see is that if we're searching for things like log.cAdvisor, which is one of the things we would have collected from our Fluentd or TD-Agent config script, which we can look at again real quick here. So we're looking for cAdvisor logs, Kubernetes, and systemd logs that would all show up. In this case, I've been collecting these logs for a while, and they're showing up here. We're seeing things like here's again code and token, describing things, the image that we're running. So we have actually not only the services, the system services running, but if we go look at our environment, we also have the simple Google Go document front end running, and so we have Redis and a front end service running here as containers, and those containers are dumping their data into Zeus. We've created a little dashboard so that we can actually visualize this, and here we have a number of the different components that are running, and we can see our log forwarders are in here, our services, etc., are all in this list, and make this go a little bit bigger, and we can move these things around, do all the fun Zeusy things within our environment. And here you can see that I'm just watching front-end resources. This was the cAdvisor services that are being polled to determine how many resources are actually running at any one point in time. And so there you can see that we're actually collecting some data into the system. And really that's what I wanted to show you. The pieces do all fit together. We're using an agent that is specific to the individual services. There's actually a script that we put together just to try to make that a little bit easier as well. This launch agent script asks for your user and your token and the target IP, and will create an agent file specific to the targeted device or targeted system that you're going to use. The nice thing about that is that this will then enable you to automatically turn these services on n number of machines rather than just one, which is what you'll want, because everywhere you have a worker, you want to actually have this this particular agent running, so they can collect data both from the general systems logs and also from the metrics from the cAdvisor output. Thanks for your time.